In the complex and highly regulated world of commercial aviation, human survival is entirely dependent on thousands of interconnected systems working in perfect harmony. But when mechanical systems reach their physical limits, survival no longer depends on aerodynamics or engineering. It depends entirely on communication. In the high-stakes environment of the flight deck, there are three very specific words designed to cut through any level of congestion, immediately halt all normal air traffic control procedures, and command the absolute, undivided attention of everyone on a radio frequency. Mayday, Mayday, Mayday. When those three words are transmitted, an invisible airspace is immediately cleared. Emergency protocols are triggered, and a specialized team of first responders begins rolling on the ground. But what happens when an aircraft is quietly falling out of the sky, running entirely on fumes, and the flight crew never speaks those three words? What happens when an exhausted crew, separated by a language barrier and cultural hesitations, uses the wrong terminology while fighting for their lives? On a dark, violently stormy night over the eastern seaboard of the United States, a massive commercial airliner carrying over 100 souls was trapped in a seemingly endless holding pattern. The weather was rapidly deteriorating. The approach corridors were choked with delayed traffic. For over 40 minutes, the aircraft had been burning through its contingency fuel, flying in endless circles in the dark. The situation was quietly becoming critical. But instead of declaring a full-scale emergency, the crew used a different phrase. A softer phrase. They pressed the radio switch and told the air traffic controller that they were declaring minimum fuel. To the crew, this was a desperate plea for help. To the air traffic controller on the ground, it was simply a routine notification of a delay. The difference in how those two words were interpreted would ultimately lead to one of the most tragic, frustrating, and fundamentally avoidable disasters in the history of modern commercial flight. And the hardest lesson learned that night was a terrifying reality that pilots now study across the globe. Minimum fuel does not mean emergency. And on this particular night, those two words were nowhere near enough to save them. To truly understand how a modern, multi-million-dollar aircraft can run completely out of fuel while in direct contact with air traffic control, we must first break down the legal and operational vocabulary of American aviation. The airspace over the United States, and specifically over massive metropolitan hubs like the Eastern Seaboard, is not just a sky. It is a highly congested, tightly controlled, three-dimensional highway system. Air traffic controllers who manage this airspace are not just looking at a radar screen. They are legally sequencing dozens of fast-moving aluminum tubes, balancing fuel loads, weather patterns, and runway availability in real time. They operate under a strict, legally binding manual published by the Federal Aviation Administration, known as J07-110.65. In this manual, words have incredibly precise definitions. They are not open to casual interpretation. When a pilot transmits the phrase minimum fuel, they are not asking to be saved. Under federal aviation regulations, minimum fuel simply means that an aircraft's fuel supply has reached a state where, upon reaching the destination, the crew can accept little or no delay. It is an advisory. It is essentially a pilot telling controller, "I'm getting tight on fuel, so please do not give me any extra holding patterns if you can help it." But here is the critical, lethal catch. Declaring minimum fuel does not grant the aircraft any special traffic priority. The controller is not legally required to move other airplanes out of the way. The controller is not required to clear a direct path to the runway. Minimum fuel simply means the controller will note your status and try not to delay you further, but you are still just another sequence in a very long line of aircraft. In stark contrast, a fuel emergency is a completely different legal state. If a pilot states declaring a fuel emergency or uses the internationally recognized distress call Mayday, 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 the rulebook is instantly thrown out the window. An emergency declaration gives the pilot ultimate legal authority to deviate from any assigned routing, altitude, or speed. The controller must immediately clear the airspace ahead of the distressed aircraft, vector other planes away, and provide the absolute most direct route to the nearest suitable runway. A fuel emergency triggers flashing lights on the radar scope. It is an undeniable, legally binding demand for immediate priority. The tragedy of the story we are examining today is born entirely in the gray area between these two distinct legal definitions. It is a story of a crew that desperately needed the priority of an emergency, but only used the vocabulary of an advisory. The context of this flight is vital to understanding the psychology of what went wrong in the cockpit. This was an international heavy aircraft inbound to one of the busiest, most unforgiving international hub airports in the United States. The flight crew had been on duty for a significant amount of time, having flown a long, exhausting intercontinental route. Fatigue is a deeply insidious factor in aviation. It degrades cognitive function, slows reaction times, and crucially, it impairs a pilot's ability to communicate aggressively and effectively. When this aircraft arrived in the terminal airspace area, the weather was historically terrible. A massive cold front had stalled over the region, dropping visibility to near zero, generating intense wind shear, and forcing the airport to drastically reduce its arrival rate. Because the airport could not accept planes at a normal pace, air traffic control had to start stacking arriving international flights into multiple holding patterns. Our flight was sent to an offshore holding fix, where they spent over 40 minutes burning through their carefully calculated reserve fuel. The crew was fully aware of their fuel state. The digital fuel totalizers in the cockpit were steadily counting down the remaining pounds of Jet A. The numbers were entirely unambiguous. But as the fuel dropped closer and closer to the absolute physical limits of the aircraft, the crew remained surprisingly docile on the radio. This introduces one of the most heavily studied psychological phenomena in human factors engineering and aviation safety. It is the concept of crew resource management and the deadly effects of cultural power distance. In many cultures, communication is highly hierarchical. Subordinates are taught to show extreme deference to authority figures. They are trained to be polite, indirect, and respectful, even in moments of high stress. In the context of this flight deck, the crew viewed the American air traffic controllers as the ultimate authority figures. The controllers spoke incredibly fast English, using harsh, clipped, rapid-fire phraseology to a fatigued, non-native English-speaking crew. Interrupting an aggressive New York air traffic controller to demand priority feels incredibly confrontational. There is a deep-seated psychological reluctance to sound panicky or unprofessional. Pilots are trained to be calm problem solvers. Nobody wants to be the pilot who declares an emergency and triggers a massive ground response unless they absolutely have to. Furthermore, there is the company pressure. Declaring an emergency often results in intense corporate scrutiny, paperwork, and investigations by civil aviation authorities. The crew falls victim to what accident investigators call planned continuation bias, deeply intertwined with the normalization of deviance. The brain constantly rationalizes the decaying situation. We have been holding for 40 minutes. Surely they will clear us to land in the next 5 minutes. We're getting low, but we can make it. If we declare an emergency, we will look incompetent. Disaster in aviation rarely happens because of a single catastrophic mechanical failure. It is almost always a slow, methodical chain of incredibly small, seemingly rational decisions that slowly paint the aircraft into a corner from which physics will not allow an escape. By the time the aircraft was finally cleared to leave the holding pattern and begin its approach to the runway, the situation had shifted from serious to absolutely critical. They had consumed almost the entirety of their safety reserves just flying in circles. But the crew, still clinging to their polite, non-confrontational communication style, told the controller, "I think we need priority. We're declaring minimum fuel." The approach controller, handling dozens of airplanes on his frequency, acknowledged the phrase minimum fuel. He made a mental note. But because the crew sounded calm, and because they specifically used the phrase minimum fuel instead of emergency, the controller assumed they simply had a tight but manageable fuel state. He did not pull other aircraft out of their sequence. He continued to give our flight standard radar vectors, extending their flight path downwind to fit them perfectly into the agonizingly slow arrival sequence. Inside the cockpit, the tension was suffocating. The fuel warning lights were now glowing amber. The massive engines were drawing the last remaining pounds of liquid out of the wing tanks. But the crew, heavily suffering from cultural deference, simply accepted the controller's long vectors. They assumed that by saying minimum fuel, they had already communicated their desperation, and that the controller was giving them the best possible route. They did not understand that in the American air traffic control system, unless you say the word emergency, you are treated as normal traffic. Then came the moment where the last remaining safety margin evaporated. The aircraft was finally established on the final approach course, descending through the heavy rain and fog toward the runway. They were completely configured for landing. The landing gear was extended, and the large aerodynamic flaps were fully deployed. This configuration generates massive amounts of drag, meaning the engines had to produce a high amount of thrust and therefore burn a tremendous amount of fuel just to keep the heavy aircraft moving forward along the glide path. They were less than a few miles from the runway threshold when the severe weather struck its final blow. A sudden, violent pocket of wind, shear, caught the aircraft. The intense change in wind direction and velocity made the airplane aerodynamically unstable. Dropping below the minimum safe altitude without the runway clearly in sight, standard operating procedures dictate only one possible action. The captain was forced to push the thrust levers to maximum power, pull the nose up, and execute a missed approach. They had to go around. Spooling massive high bypass turbofan engines to maximum thrust requires an astonishing volume of fuel. The fuel control units flooded the combustion chambers to generate the necessary power to climb away from the ground. As the aircraft pitched up and climbed back into the dark, violent clouds, the fate of the flight was mathematically sealed. A go-around had consumed the absolute last fraction of usable fuel in the tanks. As they climbed back into the holding pattern, air traffic control, completely unaware of the absolute critical nature of their fuel tanks, instructed them to climb and maintain a new altitude and vector them back around for a second attempt. It was only at this exact moment, knowing that the wing tanks were effectively dry, that the word emergency was finally spoken in the cockpit. But the agonizing reality of aviation physics is that an emergency declaration cannot magically synthesize fuel out of thin air. It was too late. There was no reserve left to manage. The sequence of a modern commercial airliner starving of fuel in flight is a deeply chilling, methodical failure of systems. It does not happen in a massive explosion. It happens in cold, heavy silence. First, the low-pressure boost pumps inside the wing tanks begin to cavitate as they suck in air instead of liquid jet fuel. Within seconds, the highly pressurized fuel lines leading to the engines lose their flow. The atomizers in the combustion chamber spray their final drops. And then, the flame is extinguished. The massive, roaring turbofan engines spool down, losing their acoustic hum, turning into massive, useless aerodynamic weights. When the engines die, the massive electrical generators attached to them also die. The brilliant, glowing glass screens of the flight deck immediately flash and go dark. The heavy hum of the air conditioning pack ceases. The cabin is plunged into terrifying darkness, illuminated only by the faint glow of emergency lighting. But the most terrifying loss is the hydraulic pressure. Modern commercial airliners are fly-by-wire, requiring massive hydraulic pressure to move the enormous control surfaces on the wings and tail. Without engine power, the aircraft automatically deploys a ram air turbine, a small emergency propeller that drops from the belly of the plane, spinning in the slipstream to provide just enough rudimentary hydraulic and electrical power to keep the plane barely controllable. The multi-million-dollar marvel of modern engineering was suddenly transformed into a 70-ton, rapidly descending, unpowered glider plummeting through the night sky. The crew fought the heavy, sluggish controls as the aircraft broke through the bottom of the cloud deck. Without the thrust of the engines, the glide ratio of an airliner configured with its flaps extended is incredibly poor. The physics were simple and brutally unforgiving. They did not have the altitude to glide to the runway. They did not have the energy to reach an open field. The heavy machine, carrying its crew and passengers, descended silently through the darkness, striking the terrain just miles short of the safety of the airport concrete. The kinetic energy of a wide-body aircraft impacting the ground is devastating, yet deeply tragic because it occurred at relatively low speeds, completely starved of the explosive fuel that usually causes post-crash fires. The wreckage came to rest in the dark, a silent monument to the terrifying consequences of miscommunication. When federal investigators and experts from the National Transportation Safety Board arrived on the scene and eventually recovered the bright orange cockpit voice recorder, they had to decode the human puzzle of why this happened. Listening to the audio tapes of the flight crew interacting with air traffic control was a haunting experience for the investigators. The audio did not reveal a reckless crew. It revealed a deeply professional, incredibly polite, and severely exhausted crew that firmly believed they had communicated their desperation. The captain and first officer were trapped in a cultural and psychological bubble where asking for priority seemed like an aggressive demand, and they assumed the air traffic controller would naturally read between the lines and understand their dire situation. But when investigators interviewed the air traffic controllers, a completely different reality emerged. The American air traffic control system is incredibly literal. Controllers are trained to handle massive volumes of traffic with robotic precision. They're not trained to guess the emotional state of a pilot. They do not monitor the fuel gauges of the planes on their radar. The controller stated clearly, they said minimum fuel, so I treated them as minimum fuel. They never said the word Mayday. They never declared an emergency. If they had simply used the correct terminology, the controller would have shut down the entire airspace, cleared all preceding traffic out of the way, and the flight would have landed safely on their very first approach with fuel to spare. The aftermath of this tragic event sent massive shockwaves through the global aviation community. It fundamentally altered the way airlines train their pilots and the way the Federal Aviation Administration mandates communication. The aviation industry realized that the cockpit voice recorder contained a harsh truth. Mechanical perfection and pilot flying skill are completely useless if the crew cannot effectively communicate a threat to the ground. This accident became the foundational case study for modern crew resource management training, specifically regarding assertiveness in the flight deck. Pilots around the world are now intensely trained to break through cultural barriers, ignore the traditional power distance hierarchy, and speak with absolute, unyielding clarity when safety is compromised. Co-pilots are taught that if the captain is failing to declare an emergency when fuel is critical, it is the co-pilot's legal duty to grab the microphone and declare the emergency themselves. The training emphasizes that nobody gets fired for safely bringing an airplane down with an emergency declaration. Furthermore, international pilot training began to heavily emphasize the specific legal phraseology required in different global airspaces. Pilots are strictly warned never to use the phrase minimum fuel if they actually need immediate, life-saving priority. Minimum fuel is a warning. Mayday is an absolute demand for survival. Today, fuel management policies have been vastly improved. Modern dispatchers use highly advanced algorithms to calculate holding times, and pilots are given hard bingo fuel numbers. Bingo fuel is the exact numeric limit where a plane must stop holding and immediately divert to an alternate airport. No questions asked, no negotiations with air traffic control allowed. The normalization of deviance, the dangerous psychological habit of accepting a slow degradation of safety margins, is heavily policed through rigorous simulator training. Pilots are evaluated on their willingness to say no to air traffic control. The industry had to learn the hard way that an airplane does not care about politeness. An airplane does not care about saving the airline money or avoiding an uncomfortable radio transmission. An airplane operates on the absolute, uncompromising laws of thermodynamics, gravity, and thrust. A commercial aircraft is the safest mode of transportation ever created by human beings. It is designed with triple redundancies. There are backup pumps for the backup pumps, but there is no mechanical backup for the human voice. The most critical component on the entire flight deck is not the navigation computer, nor is it the thrust levers. It is the push-to-talk switch on a radio panel. The story of this flight is a profound reminder of the weight of words. In aviation, words are not just communication. They are physical tools of survival, just as vital as hydraulic fluid or jet fuel. Using the wrong tool at the wrong time strips away the incredibly thin margin of safety that keeps airplanes suspended in the air. As the official accident report was published and the final safety recommendations were integrated into global pilot training, a sobering reality settled over the engineering and flying communities. Maintenance engineers can build flawless tanks, and engine manufacturers can build turbofans that run for 10,000 hours without hiccup. But none of it matters if the human element fails to speak up. A perfectly functional aircraft, fully capable of sustained flight, did not fall out of the sky that night because a critical part broke. It did not fall because it ran out of fuel. It fell because highly trained professionals, separated by distance, culture, and a rigid rulebook, spent too long hoping the remaining fuel would be just enough. They fell because they refused to speak the 3 specific words that would have instantly saved their lives.